the part nobody saw coming. What followed was an ecological collapse on a scale that shocked even the most pessimistic scientists. Without horses pounding the surface, the soil hardened into something researchers started calling biological concrete. Rain would still fall on the region 4 to 6 in every year, but instead of soaking into the ground, water would sheet across the impermeable crust and evaporate within hours. Seeds could not push through the surface to germinate. Nitrogen levels crashed so dramatically that by 1974, scientists were comparing soil samples from the basin to lunar dust. The material was still there. The grains of sand and silt still looked the same under a microscope. The basin had simply gone biologically dead. And then the desert started moving. Satellite imagery from 1982 showed the Goi expanding at 70 kilometers per decade, swallowing grasslands, villages, and farmland whole. Highways had to be relocated. Train lines were being buried. Beijing, more than 1,000 miles away, was getting hammered by dust storms that lasted for days at a time. And get this, in March of 1983, a single storm dumped 43,000 tons of Younger Basin topsoil on the Chinese capital in less than 72 hours. Hospitals reported a 300% spike in respiratory emergencies. People were choking on a desert they could not even see, breathing in the ground from a place 1,000 miles away. So China tried everything. The Green Great Wall Project, launched in 1978, aimed to plant a forest barrier 4,500 kilometers long across the country's northern frontier. But here is the catch. The trees needed more water than the desert could provide. Water tables that had been stable for centuries dropped by 12 m in some regions. The trees themselves, planted in neat rows like soldiers, started dying from the bottom up as their roots failed to reach the falling water. Whole villages had to be relocated when their wells ran dry. Engineers tried sand-fixing grids made of straw. They tried planting drought-resistant shrubs. Nothing held the line. By 1985, the situation was a full-blown crisis. Agricultural productivity in Xinjiang province had fallen by 34%. The desert was closing in on Beijing faster every year. Computer models projected that at the current rate, the Chinese capital itself would be borderline uninhabitable by 20150. And that is the disaster a small group of Chinese ecologists led by a researcher named Yong Music, Jian Ming, was staring at when they walked into a government meeting in 1985 and proposed something that sounded like fantasy. Yong stood in front of officials who had spent 2 decades watching tree after tree die, watching wells run dry, watching the dust eat their capital. And he told them to stop. Stop fighting the desert with bulldozers and tree farms. Bring back the animal that had kept this place alive since the last ice age. Bring back the wild horse. The room, by every account, did not love this idea. But the numbers were so bad, the failures so total, that within months his plan was approved, which left exactly one question hanging in the air. How could zoo-born animals fed by humans for 3 generations survive a place that was eating cities? The last truly wild horse. The Przowski's horse is not just any horse. Look at its DNA, and you will find 66 chromosomes instead of the 64 that every domestic horse has. It is the only horse species on Earth that has never been domesticated, never broken, never tamed. While humans were breeding Arabians for speed and Clydesdales for muscle, Przowski's horses stayed exactly as they had been when our ancestors were painting them on cave walls in the deep past. They are a living window into the Ice Age. The Przewalski's horse is genetically different and the only true wild horse subspecies. Music, but here is the wild part. By 1985, the window was nearly closed. Only about 900 of these animals existed anywhere on the planet, and every single one of them was in a zoo. The entire species traced back to just 12 music, to 14 individuals captured between 1899 and 1903 by Russian explorers working on commission for European zoo collectors. After World War II, the global population hit rock bottom at 31 horses, with only 9 of them capable of reproducing. At one terrifying point, the species survived in just 2 places on Earth, the Munich Zoo and the Prague Zoo. Every living Przowski's horse alive today carries that genetic bottleneck in its cells, a chromosomal scar from coming within inches of disappearing forever. The fact that there were any left to send to China in 1986 was by itself a small miracle. China's music plan, drafted in 1985 and launched in 1986, had three phases. First, import horses from Western zoos and acclimatize them at a new breeding center built in Jimsar. Second, transition them into massive semi-wild enclosures, essentially teaching zoo animals how to be wild again. Third, release them into the Kamilai Nature Reserve for 1,000 kilometers of some of the harshest terrain in Asia. Among the first horses moved into the Jimsar enclosures was a young stallion with a clean white blaze running down his face. The keepers named him Hong. Remember music, that name. Now, here's where things get interesting. Yong's argument to the government was not just that these horses would survive. It was that they would actively rebuild the ecosystem. These horses do not just eat grass. He said they engineer entire landscapes, and once you understand how the entire story stops sounding crazy, it comes down to three things. And the first one is brute force. Each horse weighs between 600 and 800 pounds. When they run, their hooves hit the ground with 800 pounds of pressure per square, in which is more force than a jackhammer. In a place like the Yungar Basin where the soil had turned into that biological concrete, this is exactly the kind of force needed to shatter the hardened crust and let water music back in. But here's the thing machines cannot do. Horses are selective. They walk around fragile young plants. They only pound bare soil and dead vegetation. They know the difference. Then there is the way they move. GPS tracking would later reveal that Przalski's horses travel about 15 kilometers a day in what mathematicians call fractal music patterns. They graze intensively in one spot for hours, then suddenly relocate miles away, then circle back. It looks random. It is not. This pattern creates a disturbance, music, mosaic. Short grass here, tall grass there, bare patches in between. Each tiny microhabitat, music, ends up supporting different species of insects, birds, and small mammals. The horses are not just eating. They are designing a patchwork. And get this, the third thing is the part that sounds the most absurd. Horse manure, it turns out, is not waste. It is a delivery system. Analysis of Przalski's horse dung revealed viable seeds from more than 20 different plant species. And the journey through the horse's gut actually improves germination rates by up to 300%. The acids in their digestive system scarify hard seed coats and break dormancy in seeds that would have otherwise stayed locked up for years. 1 g of dung contains up to 7.4 viable seedlings. That is double the dispersal rate of cattle and 8 times the rate of sheep. And because these horses travel those 15 kilometers every day, they are seeding vast areas. Music, building genetic corridors between plant populations that have been isolated for decades. Every pile of dung is, in a very real sense, a self-watering pre-fertilized seed packet. That was Yong's pitch. That was the theory. The problem was that the horses they were about to release had spent 3 to 4 generations behind bars. There are currently 900 Przalski's horses in China, a remarkable achievement for wildlife diversity. They did not know how to find water in a desert. They did not recognize the sound of a wolf as danger. They had never experienced a temperature below freezing or above 90 degrees. They had lost what the researchers called the culture of survival, the learned behaviors passed from mother to FO that no amount of raw genetic programming can replace. So, the question that would decide whether Yong was a visionary or a fool was simple. Had 3 generations of zoo life killed the instincts buried in these animals, or were they still in there somewhere waiting? Before we go any further, before I tell you what happened when these horses actually hit the ground in that desert, do me a quick favor. If you are finding this story interesting, hit that subscribe button and tap the bell. We dig into stories like this one every single week. The kind of stories that rewrite what we thought we knew about how the natural world actually works. And the next part of this story is the part nobody believed was even possible. What those zoo-born animals did in their first winter. What one stallion did on day 8 of the release. And the number researchers eventually calculated for what a single one of these horses is worth to the planet. Stick with me. The payoff is coming. A winter that should have killed them. The first months at Jimsar were a fight that nearly proved the critics right. Within weeks, botfly infestations had hit 100% of the herd. And these were not ordinary parasites. The larvae burrowed into the horse stomachs, creating painful lesions that wrecked their digestion at exactly the moment they needed every calorie to survive. Then came the first winter, and the first winter was apocalyptic. Temperatures fell to minus 42 degrees Fahrenheit. The horses, accustomed to heated barns, huddled against frozen winds that cut through the desert like razors. Their distinctive mohawk manes froze into icy ridges so thick that some horses could not lift their heads off the ground. Snow buried what little grass existed under 3 feet of powder. And here is where it gets brutal. The staff at Jimsar, Yong's team, watched through binoculars and were forbidden to intervene music unless the entire herd was at risk of dying. 7 horses developed severe frostbite. 2 mares miscarried in the cold. The international press was already writing the obituary for the project. Conservation journals were preparing autopsies of what they assumed would be a textbook failure. Yong himself, by his own later admission, was preparing for the worst. But something else, something nobody had scripted, was beginning to happen out on the frozen steppe. The stallions started breaking the ice with their hooves to reach the water beneath, a behavior never observed in captivity in any zoo anywhere. The mares started forming protective formations around their fosse during storms, using their own bodies as windbreaks and rotating positions. When one mare got too cold, the horses learned to dig through snow with a sweeping motion of their front legs, uncovering grass that no domestic horse would have ever thought to look for. They started reading the wind, recognizing which slopes had been swept clear by the cold and which had banked deep with snow. And that is putting it lightly. They were not just surviving, they were remembering. Generations of zoo life had not erased what was written in their bones. The instincts were still there, dormant, waiting. The desert was waking them up. By the spring of 1987, the change accelerated past anything the project had projected. Grass species that had not been seen in the basin for 17 years started sprouting in the areas where the horses had grazed. Compensatory growth, the phenomenon where grasses grow back faster and thicker after being clipped, increased biomass by 43% in grazed areas compared to ungrazed controls. The horses were not destroying the land, they were stimulating it. The soil itself began to change in ways that stunned the scientists monitoring it. In that first year alone, moisture retention jumped 23%. Not because the rain had increased, not because the climate had shifted, because the horses' hooves had hammered roughly 10,000 tiny craters into music every hectare of land. Each one of those depressions became a miniature reservoir, catching precious rainwater that would have otherwise sheeted off the hard pan and evaporated within hours. The horses were rebuilding the basins, plumbing one footstep at a time. The second year brought another shock. Nitrogen levels surged 37%. The horse manure was not just fertilizing the soil. It was reintroducing the gut bacteria the soil had been missing for decades. An entire microbial community that had vanished when the wild horses vanished. By the third year, botanists were documenting something that should have been impossible. 22 plant species had returned from nowhere. Their seeds apparently had been lying dormant in the soil for nearly 2 decades, waiting for the right conditions to germinate. The basin had not been dead. It had been sleeping, waiting for the one species that knew how to wake it up. But here is the deal. One winter survived is not a population restored. The horses still had to do it again, music, and again. And the second winter, when it came, was going to test whether that first miraculous season was the beginning of something real or a one-time fluke. The ecosystem wakes up. It was not a fluke. The horses survived the second winter and the third and the fourth. And once the plants came back, everything else followed. Dung beetles, absent from the basin for 15 years, returned by the millions. They buried horse manure, further enriching the soil, accelerating the recovery loop. Field surveys started counting 43 insect species that had not been recorded in the region for decades. The insects pulled in the birds. Larks, wheat ears, and sand grouse moved in to feed. Small mammals followed the birds. Gerbils, pikas, ground squirrels, music, and then the predators came back. Foxes, steppe eagles, even the occasional gray wolf began to show up on the camera traps. Each new species added another layer of complexity, another feedback loop, driving the recovery forward. By the late 1990s, the herd at Jimsar had grown enough, and the basin had recovered enough, that Yong's team made a decision that would have sounded insane a decade earlier. They were going to take the fences down. In August 2001, the project entered its boldest phase. 27 horses were selected for full release into the Kolo Mile Nature Reserve. No fences, no supplemental feeding, no human intervention of any kind. Just horses in 4,000 kilometers of desert that had not seen their kind in 32 years. Among the 27 was Hong, the stallion with the white blaze, now fully grown and leading his own harem. The scientists fitted GPS collars, set up camera traps, and held their breath. For the first week, the horses stayed within 500 meters of the release point, almost as if tied to invisible chains. They drifted in circles. They grazed nervously. They kept looking back toward the pens. And then came day 8. Day 8. It was just after dawn. The wind, according to the field notes, was running steady out of the northwest. Music. The GPS team at the monitoring station was watching the screen mostly out of habit at that point, when one of the dots on the map started moving. Then the dots around it started moving. Hong was on his feet, and his harem was falling in behind him. He did not drift. He did not graze. He walked north in a straight line like he knew exactly where he was going. The dots kept moving 5 kilometers 10-15. The monitoring team started making phone calls. By the time Hong stopped, he had led his harem 30 kilometers north to a water source that did not appear on any of the project's maps. Nobody had told him it was there. No previous generation of his bloodline had walked that road in his lifetime. He simply knew. The team drove out the next morning to confirm what the GPS had already told them. And there it was, a spring-fed pool, half-frozen, tucked against a low ridge. Hong was standing next to it like he had been visiting it his whole life. How he knew remains one of the great unsolved mysteries of the operation. Some ancestral memory, some scent on the wind, some pattern in the geology that horses can read and we cannot. Within a month, the horses had carved out territories. The stallions were marking boundaries, with dung piles placed deliberately on raised ground. Natural foaling rates hit 87% higher than what most zoo populations could achieve. And the FO being born out there in the wild were displaying behaviors captive-born horses simply do not show. They could distinguish 23 different plant species by smell. They responded to the shadow of a golden eagle by freezing instantly. They grew thicker winter coats than their parents, and the landscape change was now visible from space. Satellite imagery showed green patches expanding music outward from the horses' core territories, like slow-motion explosions. The water table, which had been dropping by 3 centimeters every year since 1970, stabilized in 2003, and then it started to rise. The horses had switched back on a hydrological pump that had been off for a generation. The number that broke the model. What was happening in the Yungar Basin shattered everything China thought it knew about fighting deserts. For 25 years, the Green Great Wall had been built on one premise: plant trees to music, stop the sand. By 2010, China had planted 66 billion trees at a cost of 47 billion. And in many regions, the trees had made the underlying problem dramatically worse, pulling water out of the ground faster than the land could replenish. And here is the part that should have changed everything. While China's massive tree planting program was literally drinking the desert drier, the horses were doing the opposite. They were bringing the water back. Their hooves were creating infiltration points that let rare rainfall penetrate deep into the soil instead of evaporating off the crust. Their grazing was maintaining music grasslands, which require 90% less water than forests. A single horse was improving water retention across 50 hectares every year. Then somebody did the math, and the numbers stopped sounding like ecology and started sounding like economics. When ecological economists sat down to calculate what a single Pritzvolsky's horse was actually worth to the surrounding ecosystem, they came back with a figure nobody expected. Soil restoration valued at $12,000 per horse per year. Seed dispersal $8,000. Water retention $15,000. Carbon sequestration $7,000. Biodiversity support $5,000. Total $47,000 per horse per year. When they ran the cumulative number, The economists were the next ones after the BBC crew and the conservation journals to need a second look at their results before they trusted them. Because by 2023, those 11 horses had become 534. The herd was effectively managing 26,700 hectares of land, an area larger than many national parks, generating $25 million in ecological benefits every single year. And that was a conservative estimate that did not include tourism, scientific research value, or what the basin was now worth in carbon offsets. Among those 534 horses, by then were Hong's descendants, dozens of them scattered across the reserve in harems of their own. The dead soil they had been released onto now supported over 20 species of plants that had not grown there in decades. And the desert that had been expanding by thousands of square kilometers every year was now retreating, pulling back at a rate of 47 hectares every year in the zones where these horses roamed. The model spread fast. Mongolia released horses in Hustai National Park in 1992, and by 2023 the population there had hit 490 individuals, with the surrounding steppe showing the same restoration patterns as Xinjiang. Kazakhstan launched its Golden Steppe project in 2024, transporting horses from Prague and Berlin into the Kasta region. 8 years later, there were more than 100. Now nearly 1,000 have been released to roam Central Asia. Russia has been quietly studying the Chinese data. Each project kept proving the same principle. You cannot engineer an ecosystem from the top down with human designs and concrete. You have to restore it from the bottom up with evolutionary solutions that have already been tested over thousands of years. China is now expanding the Kalamali Reserve by another 350 kilometers. The official goal is 2,500 wild horses by 2040. The computer models suggest a population that size could restore more than 100,000 hectares of degraded land, lock up 43,000 tons of carbon every year, and support more than 300 species of plants and animals that currently exist nowhere else in China. If they pull it off, the Yungar Basin will become the first desert in human history to be reversed not by planting, not by irrigation, not by engineering, but by the hooves of wild horses. The 11 animals that stepped off that cargo plane in 1986 were not just a few endangered animals being relocated. They were biological technology refined by evolution over hundreds of thousands of years, capable of designing and maintaining an entire landscape. We just had to remember how to switch it on. We just had to stop trying to do it ourselves and let the experts, the ones with hooves, take over. The Perciwalski's horses force us to ask an uncomfortable question. How many of the environmental disasters we are facing right now could be solved by bringing back the original engineers we drove to extinction instead of throwing trillions of dollars at human design fixes that do not work? The bison that shaped the American prairie, the wolves that maintain the forests of Europe, the elephants that garden the savas of Africa. We have spent the modern era trying to engineer nature. Nature had already engineered the solution. We just killed it, and then we forgot the recipe. Drop your thoughts in the comments below. If you could bring back one extinct ecosystem engineer anywhere on Earth to repair land we have ruined, which species would you choose and why? I read every comment. And if you want more stories about animals that have literally reshaped continents, the subscribe button is your next click.